So continuing in section 3.4, we're looking at real zeros of polynomial functions. So this is the name of the function. Okay, it's another rule that helps in determining roots of higher degree polynomials. You and I have already done this, okay? But now just to give a name to it, all right? So the rational zero test, or the rational root theorem, applies to polynomials with integer coefficients only. So make sure you notice that. Okay, every rational zero has the form of P over Q. This is what you and I called plus or minus last over first. Okay, so this is what we called plus or minus last over first. They're just using P and Q, where this is the same thing as us. The last, or the P, was a factor of the constant term, and the first, or the Q, was a factor of the leading coefficient, as long as you've got your polynomial in descending order. Okay, so now that you have a name for it, let's talk about the expectations with calculator and your work by hand. Okay, so you do want to practice both. Okay, you want to be able to do these problems that we've been doing in the past by hand. But we want to not have your homework take hours upon hours just for one single problem, okay? So here's what you should be thinking to do. So let's pretend, now that we've given you that rational root theorem, and you know how to find your roots that we've been doing for a few days, then I'm just going to make this up for a minute. Let's pretend that you did your possible roots, which is, this is the first thing you'll do on every problem. You'll do this by hand. So let's pretend our possible roots done by hand are plus or minus 1, plus or minus 2/3, plus or minus 5/7, and plus or minus 5/2. Okay, then use your calculator to help you limit the number of answers. I know there's only 8 the way I put it up there, okay, but still, it could take a little while with some of the fractions. But use your calculator to limit the number of answers and give you some better guesses to put in the batter's box, if you will, before you even start. Okay, and then still you're going to show all of the work by hand. So by this, I'm saying if you put in your calculator, you've got a couple options. So either you would write, you'd put this into Poly, and we'll say either write Poly gives, and based on those answers, it's going to have some nice answers, right? It might say like plus or minus 1, and then it might say plus or minus 2.5, right? Because 5/2 is 2.5. But if it says a decimal that goes on, or it says something about I or whatever, I'm just going to ignore those, okay? So I'm just going to use the nice ones from Poly. I might say Poly gives x equals 2/3, right? So 0.6 repeating, and negative 5/2. And then show the rest of the work by hand. And by that I mean, now take your 2/3 that you are pretty positive is going to work, put it in the batter's box, do your work, right? We would have a line here, get your remainder, and your remainder better be 0, okay, if it is a root. And then, of course, into the depressed equation, you'd put negative 5/2 in the batter's box. The order does not matter. Okay, your work might be different than your friends or mine if you put the negative 5/2 and the 2/3 first, if you flip-flop that order. But in the end, our final answer should be the same. So there's your lines of work, your boxed answer, okay, or your boxed remainder, I should say. And again, that has to be 0. Your whole goal, guys, You used the calculator to limit it down so that you knew these two were pretty likely going to work. You verified it because you make sure that these remainders ended up 0, okay, from what we talked about. And then hopefully at this point, you're either down to a quadratic or a quadratic type where you can factor it the rest of the way by hand. Okay, so we're letting you use your calculator to limit the number, but you're still showing me everything by hand. Okay, afterwards. Your other option, so that's if you really love poly. Your other option is graph. So I'll say or graph it and estimate good guesses, if you will. So on that note, I'm talking about, let's say I had this graph, okay? And I don't have arrows on the end simply because I'm just focused in on this part. I have no idea what it's doing out here, okay? Something's going on, maybe whatever. Okay, I don't care about that part. I'm focused in on the ones from the possible roots I've already done by hand. Okay, so if I have done a good job with my graphing and my scale, and I know that this is -1, this is -2, and -3, well, now I'm using this graph to say, ooh, I know this crosses somewhere between -2 and -3, which means a good guess from my possible roots up above is -2.5. So I'm going to put -5/2 in the batter's box. Okay. Likewise, over here, I notice if I'm counting by ones, and this is 1, this is crossing somewhere between 0 and 1, okay, at that point. Well, somewhere between 0 and 1, now I have a hard time estimating, is that really a 2/3 or is it a +5/7? Because both of those are between 0 and 1. Well, at least you've eliminated the negative of each of those. Okay, so that's what we're talking about. Limit your possibilities using your calculator, whether it's using a quick graph or poly. Maybe you want to master both quickly. And then you'll do exactly like I just did above. You'll do all work after that by hand. All work after that by hand. And I should also just see you. Okay, maybe just draw me a quick sketch or say the graph gives x equals da 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 da. Possibility of dot dot dot. Poly gives x equals this and this. Okay, and then finish your work by hand. So utilize the calculator when we're allowing the calculator and limit it down. Let's practice that a little bit. So here we go. In problem 1, go ahead and turn off the video and list the possible rational zeros for me. All right, let's see how you did. So possible rational roots, make sure you have plus or minus in front of each of them. Be very systematic about it. Like I do 1/1, 2/1. I do all of them over 1, then I do all of them over 2. Make sure you're reducing and you don't include one that already reduces to something you have as a possible rational zero. Okay. Go ahead and get on your own graphing calculator, the way we just talked about, to narrow down some choices and come back. All right, so you might be finding that poly or a graph gives x equals -2 is a good number to start with. Please notice we're finding all the real zeros. I also notice it started out as cubic, so really one nice one is all I need because that will depress it down to a quadratic, and I know what to do with a quadratic always. So if I bring that down here then, and it says go ahead and use synthetic division to find all the real zeros, then that means -2 is what goes in the batter's box. Why don't you go ahead and completely finish this and see if you can find all the real zeros yourself and then come back. All right, let's see how you did so far and add a few details before I box my final answer. Okay, so if you put -2 in, yes, you should be getting 0 as your remainder. Remember, we like to call this, just for a little review, r of x. This should also be, our original function was g, so please be consistent using letters. This should also be g of -2, just for practice with this chapter. That means g of -2 equals 0, and that the ordered pair -2, 0 is on the graph of g of x. Now, if you're down here with your depressed equation right there, that quadratic, however you're going to solve it, you should notice it doesn't factor. Of course, that's what I'm going to try first. If not, drop to the quadratic formula. And then please don't get so involved. This is what a lot of people like to do. They get so involved in going through that and getting the 1 plus or minus the square root of 145/8 that they stop there. But remember, this is a cubic. It should have 3 answers. Okay, and don't forget the obvious one that you already had in the batter's box. So don't forget the -2, and therefore that is your final answer. Okay, so that's how you're going to use your calculator to help you limit it down. Now, we have quite a few true-false questions that come up in pre-calc and AP Calc, guys. True-false in those classes are not, and exactly same in this class, are not just you writing true or false. It's you showing work. If it's false, you kind of showing what the right answer is. So just to start practicing with some of that stuff, let's try out this problem. So if I give you x to the 8th and ask you, if I give you that whole polynomial and ask you true or false, and say theoretically this could have 8 imaginary roots. All right, think about what we've talked about. Imaginary roots come in pairs, so don't forget that. Okay, and they come in conjugate pairs. So if they come in pairs, can pairs add up to 8? Or I might be thinking about the end behavior for something that's x to the 8th. Okay, either way, you should be able to come up with some sort of answer. Like, for instance, you should be saying like this is true. Imaginary roots come in conjugate pairs or in pairs. Talk about something about x to the 8th. You could show your arrows. Okay, I would know what you're talking about. And just think about this. If we're saying it has imaginary roots, doesn't cross the x-axis, if both arrows are going up, do you agree that it could be all above the x-axis? Right? Ultimately, maybe it looks like this. Maybe everything's above the x-axis. Here's your x-axis. Okay, x and y. So that could be what's happening. So some sort of explanation, guys, to back up your true and false. Okay. Let's practice another. So a couple questions on this one. Same problem, but I might not have the same question. All right, so for the first one, what if I just gave you the cubic and I said this could have 3 imaginary roots? Hopefully you're thinking that is false. And saying something about, well, imaginary roots come in conjugate pairs. Right? Which means pairs would be 2 imaginary roots or 4 imaginary roots. You can't have 3 of them. Okay? Or vice versa, I might only ask you this question, give you the cubic and say, this must have at least 1 real root. Okay? Hopefully you're thinking this is true, and maybe you're showing something about the end behavior of x cubed. Okay, explaining that it would look something like this, and therefore it would have to cross the x-axis, okay, somewhere in there. Or talking about, or maybe you're doing both, or talking about imaginary roots. Again, come in pairs, conjugate pairs. And so that could get you 2 of them, but the third one would have to be real. Okay. All right, so just start working with those true, false. Here's a different one, different kind, guys. So on this true and false, I'm giving you h of x and asking you, or making the statement, true or false, the vertex of h of x is in quadrant 1. Okay. Again, you just simply tell me true or false, and I don't see enough work, no credit. Okay, so you must back this up with work. All right, so the first thing I'm going to do, if they're asking me about a vertex, I'm going to do the work and find the vertex. So h of x, I'm going to be completing the square. So I've got to take the x, or sorry, the 2 out of the x squared and the x term. Remember, we're going to add a blank and also subtract a blank from the same side to keep it balanced. And that negative 13, that constant is always going to go at the back. So completing the square, the middle coefficient, the 2 cut in half is 1, squared is 1. But think about what you really added to keep this balanced. You really added 2 times that 1 in the parentheses. So if you added 2, you've got to subtract 2. Okay, so now this is 2 x plus 1 quantity squared minus 15. So the vertex, like in your work, I want you to flat out tell me what the vertex is. Your HK vertex is -1, -15. Okay, so I would be looking for that for work. And then review of your quadrants. Remember, quadrants are always Roman numerals, and they start in the upper right. There's 1, 2, and they form the letter C. Here's 3. Again, always Roman numerals, and then IV for 4. There's your quadrants. So if I see you label that, and then quickly give me that that ordered pair is at -1, -15. I don't need it accurate to scale, but if you tell me -1, -15, like that, and then you now tell me that your answer is, well, it says that this vertex is in quadrant 1. No, you would be telling me false and what quadrant it actually is in. So you don't change the question, you make it so that the question is true, okay, if you will. So you're just justifying this and saying false, the vertex is in quadrant 3. Okay, so when it's false, you give me what the true answer would have been. And remember, quadrants are Roman numerals. There you go. There's a little practice with true, false. We will keep working with those.